Welcome to G Fun Facts Online. Today, we're talking about a machine that looks like it flew straight out of a 1950s science fiction comic book, but is in fact the most advanced and powerful rocket ever conceived. We're talking about SpaceX's Starship. This colossal vehicle isn't just about reaching orbit. It's designed to build a city on Mars. Let's break down the incredible engineering that's making this audacious dream a reality. The core idea behind Starship is a concept that has been the holy grail of spaceflight for decades: a fully and rapidly reusable rocket. This is the paradigm shift that changes space exploration from a series of expensive, one-off missions into something more like commercial aviation. When the Super Heavy booster and the Starship spacecraft are stacked together, the entire vehicle stands an imposing 123 meters tall, or about 403 feet, with a diameter of 9 meters. It's designed to lift between 100 and 150 metric tons to low Earth orbit. To put that in perspective, that's like launching an entire blue whale into space. The truly revolutionary part is that after launch, both the booster and the upper stage spacecraft are engineered to fly back to Earth, land vertically, and be prepared for another flight in a matter of hours or days. This is the key to slashing the cost of accessing space and making a city on Mars economically possible. Perhaps the most striking and debated decision about Starship is what it's made of. When you think of advanced aerospace, you probably picture sleek, black carbon fiber composites. SpaceX initially planned to use that, but then made a hard pivot to something much more old school: stainless steel. Why? There are three main reasons: cost, manufacturing speed, and performance at extreme temperatures. Elon Musk has pointed out that while carbon fiber is incredibly strong for its weight, it's expensive to produce, costing around $150 per kilogram. The stainless steel alloys they use? About $3 per kilogram. This massive 50-fold cost difference is crucial when you plan on building hundreds or even thousands of these vehicles. But it's not just about cost. The performance of stainless steel at extreme temperatures is phenomenal. On one end of the spectrum, at the cryogenic temperatures of its liquid methane and oxygen propellants, certain steel alloys actually become stronger and tougher. Then, during the searing heat of atmospheric re-entry, it maintains its strength far better than carbon fiber, which starts to weaken above 200 degrees Celsius. The steel's melting point is around 480 degrees Celsius, or 700 Fahrenheit, giving it a huge thermal margin. This resilience to heat means Starship needs a less massive heat shield. SpaceX has even developed its own custom alloy, called 30X, which is a modified version of 300 series steel, designed to be stronger and lighter than off-the-shelf versions. This custom alloy is also planned for use in Tesla's Cybertruck, potentially creating economies of scale that drive the cost down even further. Crucially, building with steel is more like welding together a water tower than crafting a delicate composite structure. This simplifies manufacturing and enables SpaceX's famous build, fly, break, repeat development philosophy. Powering this stainless steel giant is an entirely new class of engine, the Raptor. The Super Heavy booster has a staggering 33 of them, and the Starship upper stage has 3 for sea level and 3 optimized for the vacuum of space. These engines are an absolute marvel of engineering. The Raptor is the first operational engine to use what's called a full-flow staged combustion cycle. It's a very complex design, but the key takeaway is that it's incredibly efficient and allows the engine to run at higher pressures but with cooler internal temperatures. In this cycle, both the fuel and oxidizer are partially burned to power their own turbopumps, and then all of that propellant flows into the main combustion chamber. This full flow means the turbines run cooler, extending the engine's life and making them much more reusable, which is the name of the game. The fuel choice is also strategic. Instead of the typical RP-1 kerosene used in their Falcon 9 rockets, Raptors burn liquid methane and liquid oxygen, a combination called methylox. Methane burns much cleaner than kerosene, which means less soot builds up inside the engine, making it far easier to service and reuse. But the real genius of this choice is looking ahead to Mars. Methane can be produced on the Martian surface by combining carbon dioxide from its thin atmosphere with water ice found on the planet. This process is called in situ resource utilization, or ISRU, and it's the key to making return trips from Mars possible without having to haul all the return fuel from Earth. Just like the rocket itself, the Raptor engine has evolved rapidly. Raptor 1 was the proof of concept, complex, and covered in sensors to gather data. Raptor 2 was a major redesign, focused on simplification and manufacturability. Many parts were welded instead of bolted, redundant sensors were removed, and the cost was cut in half, while simultaneously increasing the thrust from about 1.8 to 2.3 meganewtons. The latest version, Raptor 3, is even cleaner, more powerful at 2.8 meganewtons of thrust, and relies heavily on advanced 3D printing to create a more integrated and producible engine. This rapid evolution is a core part of the SpaceX philosophy, and that philosophy extends to manufacturing. At their sprawling facility in Boca Chica, Texas, SpaceX is building what they call the Star Factory. The goal isn't just to build a few rockets, it's to mass produce them. The ambition is a production line that could eventually build up to 1,000 Starships a year, a rate completely unheard of in the traditional aerospace industry. The process starts with giant rolls of stainless steel, which are cut, formed into rings, and then welded together. In the early days, this was done manually and tense, using techniques like flux-core arc welding. Now they've moved to using robotic welders with advanced techniques like tip-TIG and even laser welding, which produce cleaner, stronger, and more consistent seams. Because welding can soften the metal, they use a giant planishing machine to hammer the welds, compressing them to make them just as strong as the surrounding cold-rolled steel. The domed caps for the propellant tanks are especially challenging, as they have to contain super-chilled high-pressure liquids. SpaceX developed a custom knuckle seamer that perfectly aligns the dome segments before an automated torch performs the weld. This factory approach is how SpaceX plans to build the fleet needed for a Martian city. Now let's talk about one of the most visually stunning parts of a Starship mission, the re-entry and landing. After its mission, the Starship spacecraft re-enters the atmosphere not nose first, but belly first, in a maneuver affectionately called the belly flop. It uses its 4 large flaps, 2 at the front and 2 at the back, to control its descent, much like a skydiver uses their arms and legs to control their fall. By adjusting the angle of these flaps, the vehicle can control its pitch and roll to maintain a stable, horizontal orientation. This belly flop maximizes the vehicle's surface area, creating a huge amount of aerodynamic drag. This is how it slows down from orbital speeds of over 27,000 kilometers per hour, passively shedding the vast majority of its kinetic energy as heat, which minimizes how much fuel is needed for the final landing burn. To survive this fiery plunge, where temperatures on the leading edges can hit 400 degrees Celsius, the entire windward side of Starship is covered by a thermal protection system, or TPS. This consists of about 18,000 hexagonal black tiles made from a silica-based ceramic material. The hexagonal shape is clever. It prevents hot gas from finding a straight path through any gaps that might form between the tiles, which could damage the hull. Each tile is attached to the steel hull with a single pin, in a system that allows it to expand and contract with the extreme temperature changes without breaking. And just in case a tile is lost, there's a secondary ablative layer underneath, likely a pyron-based material, that's designed to burn away and carry heat with it, providing a crucial backup to ensure the vehicle's integrity. In the last moments of the descent, at an altitude of just 500 meters, Starship performs its most dramatic move. It ignites its Raptor engines, which then gimbal or pivot to flip the entire 50-meter-tall vehicle from its horizontal belly flop position to a vertical tail-down orientation for landing. This is an incredibly complex aerodynamic and propulsive ballet, From there, it performs a final landing burn to touch down gently on its landing legs. Or, even more audaciously, to be caught. This brings us to Mechazilla. That's the nickname for the nearly 145-meter tall, or 475-foot, launch and catch tower. This isn't just a platform to launch from. It's a core part of the reusable system. The tower is fitted with a pair of massive robotic arms, often called the chopsticks. These arms first lift the super heavy booster onto the launch mount, then stack the Starship spacecraft on top. But their most revolutionary job is to catch the booster as it returns to land. Instead of landing on legs, the super heavy booster slows to a hover next to the tower, and the chopsticks close around it, grabbing it by reinforced hardpoints on its sides. This brilliant move saves the weight and complexity of putting landing legs on the massive booster, and allows the tower to place it right back on the launch mount for rapid restacking. The plan is for the Starship spacecraft to be caught in the same way. The precision required for this maneuver is immense, needing a guidance, navigation, and control system far more accurate than standard GPS, likely using a combination of onboard sensors and ground-based signals from the tower itself. But even with all this power, Starship can't get to Mars on a single tank of fuel. It uses most of its propellant just to get into low Earth orbit. A single Starship launch to LEO is like driving a car to the end of your driveway. You need a gas station to go on a real road trip. This is where orbital refueling comes in. SpaceX plans to use a specialized tanker version of Starship, which is essentially a flying gas can. A crewed or cargo Starship will launch into a parking orbit, and then several of these tanker Starships will launch, rendezvous, and dock with it to transfer more liquid methane and oxygen. This on-orbit refueling is the absolute key that unlocks the solar system. It allows a fully fueled Starship to depart from Earth orbit, carrying the hundreds of tons of cargo and passengers needed for ambitious missions to the Moon and Mars. Transferring supercooled cryogenic propellants in a zero-gravity environment is a huge engineering challenge. The fuel can slosh around, you have to prevent vapor from getting in the transfer lines, and you have to manage the fuel boiling off into gas over time. To solve these problems, SpaceX has a tipping point contract from NASA to conduct a large-scale demonstration, which will involve transferring 10 metric tons of liquid oxygen between tanks on a single Starship vehicle in orbit. This is a crucial step to proving the whole interplanetary architecture works. The entire development of Starship has been a masterclass in iterative design. The philosophy is simple: build, fly, break, learn from failure, and repeat. We've seen this with the early Starhopper tests, the high-altitude flights of the sulfur mononitride series prototypes, and the recent integrated flight tests. After the first orbital test flight in April 2023 ended in an explosion, SpaceX made over 1,000 changes to the vehicle and the launch site. Key among these was the introduction of a hot staging technique, where the upper stage engines ignite to push away from the booster before separation is complete. This adds thrust and simplifies the separation event. They also added a massive water deluge system at the launch pad to absorb the powerful acoustic energy from 33 Raptor engines firing at once, which had destroyed the concrete pad on the first flight. The development path is laid out in a series of blocks. Block 1 vehicles were the first orbital test articles. Block 2 vehicles are next, featuring larger propellant tanks, a more angled design for the forward flaps, and other refinements. And Block 3 and beyond will incorporate even more powerful Raptor engines and a more advanced heat shield, all optimized for rapid reusability. This relentless, iterative cycle, while sometimes appearing chaotic and resulting in spectacular explosions, is what has allowed SpaceX to progress at a pace that has completely shaken up the traditional aerospace industry. And it all comes back to one ultimate goal: establishing a self-sustaining city on Mars. Starship is not just a bigger rocket, it's the vehicle designed to make humanity a multi-planetary species. The vision is a future where a fleet of Starships, launching in quick succession, can transport the thousands of people and millions of tons of cargo needed to build a permanent, independent human settlement on the Red Planet. The road is long and filled with immense challenges, but with every new prototype, every successful engine test, and every steel ring welded into place at the Star Factory, that science fiction dream is being forged into a very real, very shiny stainless steel reality.